Hello everyone and welcome back to this video. In this video, we will take a look at how to build services. We will take a look at two different services, one with persistence and one without persistence, which is basically attaching to the database. And we will take a look about the differences between Spring and Quarkus. Then, without further ado, let's dive in. Okay, so this is my IDE. From GitHub, we need to check out our Corley service. There is a link in the description. And then right away, we can start the so-called application class, which is the main class for everything. So we start this thing. And now we will see that it will tell us that we can access the application on port 50,900. So we go into a browser and say localhost 50,900. So what we see now first is that we need to authenticate. So we have the super secret user here, which is called admin. And then we can access our web page, which is basically the so-called Corley service. This is the one without persistence. The Corley service has different links. It has functional links and it has some technical monitoring links. So for the functional links, we have a method which is called say my name, which is not doing a lot. It can just give us a name. So for example, if we say my name Heisenberg, it gives us Heisenberg. Or if we say, for example, Zoidberg, we will get Zoidberg as a so-called query param. So we can go back. We have say my other name, which is just another example of doing a REST call. And we have some so-called sleep timer, which is basically only for purposes. So this is just a small demo application. We will later take a look into the code, how we can build some REST endpoints. What we also have here are monitoring endpoints, because every time we want to deploy an application, we usually need monitoring. We have a so-called health endpoint, which gives us some details about the service. So is the service running? If there is a database, is the database up? And also disk space. We have a Prometheus endpoint, which gives us more details about our application. If we are running, for example, in a Kubernetes cluster, which usually needs Prometheus to provide additional metrics to the system. We have the so-called Swagger API or Open API definition, which gives us automatically documentation about our system. And this also gives us the ability to execute our REST methods. And we have so-called Jaeger here. There is no link here to get Jaeger up and running, which is so-called distributed tracing. We need to start up Jaeger. And now Jaeger is up and running. And now every time we do a request against our REST endpoint, we can take a look here in our Jaeger system. We select the Corley service, find traces. Now we see so-called traces and spans that give us some details about the REST calls we are doing. This does not make a lot of sense if we only have one system. It makes more sense if we have distributed. So if we have one system calling another, because we will get more spans here. Okay. So these are the endpoints. Then let's take a look into the code. So as we already said, our entry point is the application class here, which basically bootstraps the application. Additionally, of course, we need, with Maven, we need a so-called POM, which basically sets up all the libraries and gives us also the setup for our compiler. As we see here, this requires a JDK 17. If you don't have a JDK 17 up and running currently, you can just decrease the compiler version to Java 11, and then it would also work with Java 11 JDK. But yeah. Then, of course, we need dependency. As we have a web application, we, of course, need for Spring Boot Starter Web. And then we have all this monitoring stuff here, which we see here for Health, Prometheus, Swagger, and also for Jaeger. Actuator is for Health. We have Prometheus. We have Spring Starter Sleuth and Zipkin for the distributed tracing, and we have OpenAPI for the OpenAPI Swagger stuff. The nice thing is we only need to include the libraries, and then automatically we get all these endpoints here. And that's it. We don't have to configure it. This is called so-called auto configuration by Spring. So Spring just basically looks into the class path of our application. It finds the libraries and then configures the libraries. The web page you see here, this very simple web page, can be found under resources static index HTML, and there we have the index HTML, but this just points to the endpoints that Spring auto configures for us. So these are the dependencies. We have some code generation, which is called Lombok. We also have security for the authentication you saw before, some other stuff here, and of course, libraries for testing. So, and what we also have is the application YAML, which gives us configuration for applications. So server port gives us the port that we can access the application, which is this one here. We can say how many threads our application has. These are the endpoints that can be configured, some configuration concerning Spring Zipkin, so for the distributed tracing. Here we can switch on and switch off authentication. This is of course something you will not do in production to have this configurable, and additionally we have logging configuration here. This is the basic project setup. And now a deeper look into the code. Just beneath our application, we now have so-called layers in our application. We have a service layer, we have a logic layer, and later on in the other applications, we will see other layers. So the service layer is the one that represents our service to the outside world. So this basically gives us all the REST endpoints that we have here. In Spring, this is done by REST controller and request mapping. I won't get into too much details here because there are far better videos to tell you how you can configure REST with Spring. Just a very broad view here. So we have our methods here, say my name, say my other name, and then we can say get mapping, and then we have the resource that follows here. Callies, say my name. So this is conducted from this resource together with the name of get mapping. So this gets callies, say my name. And we also have a parameter, a so-called rest param in one case and a path variable in the other case. So in this case, it's a so-called path variable. So this is indicated by this /, and the other one is indicated by a query param. This is this with the quote. There is not a lot more that is going on in the service. However, the service has to hold its data. And this is encapsulated in the so-called DTO. So the thing that is returned is this. It's basically a message. This is just a so-called POJO in Java, which only has one attribute. And then we have all these funny annotations here that are provided by Lombok, which is basically giving us getters, setters, builders, equals, and hash code. This is stuff you usually need for DTOs. From Java 17 on, there are now other alternatives, so-called record classes, which can help you to omit all of this, and it will just look like this. Okay. Then I have to revert my project because my IDE is funky. From the service class, we delegate to the so-called logic class, which is here. And this encapsulates our basic application logic. There is, again, not a lot here because this will just return a static message. So say my name will just have a builder here, and it will just return your name is, and so on and so on. So nothing unusual going on here. That's most of the application implementation you need to get a basic service up and running, also with monitoring. We have another package here, which is called Crossfunctional, which gives us some so-called cross-functional things like the security configuration. So our login with admin is encapsulated here. So we have the user here and the encrypted password. But again, this is not meant for production. This is just for the sake of the demo. We have an exception handler here. Whenever an exception gets thrown by the application, this will be mapped to an HTTP code. And we also have a so-called duration logger here, which gives us with every time we access the application, let's take a look if this works, we get a nice log entry. This is what we use a duration logger, say my name, say my other name. So every time we access the application, we get the name of the class, the name of the method, and how long it took. So as we see here, it did not take very long. And this is done by so-called aspects. So instead of saying into every method log.info, blah, and also in the other one, and also in the other one, we can have a so-called aspect that does this automatically for us. Okay, that's for Spring. Now let's take a look into the alternative with Quarkus. So we just switch the projects, and from a first sight, I think you won't see a difference here. We can bring up our application. It's the same. We have an application class in Quarkus, and we can access our endpoint. To shut down my windows here. Looks very similar. It's basically the same stuff, just with another framework. So we can again say my name. Okay, I have to log in into this application, also with admin. I have the other endpoints. I also have an health endpoint. I also have a Prometheus endpoint, and I also have Swagger API and also Jaeger integration here for distributed tracing. If we take a look into the POM here, it also looks very similar. We have the dependencies we need for the web. We have the dependencies need for monitoring. Of course, with Quarkus, we have other dependencies, but this will yield to the same results as our Spring application. And for security, we also have this thing here for security, and it's very similar. So what is the difference between Quarkus and Spring? Quarkus can give us so-called native images, which use much less RAM. So a standard Spring application can consume up to 400 megabytes of RAM, while a standard Quarkus application only uses 20 megabytes of RAM, which is less than a 20th of RAM. There is another link in my YouTube channel you can find about Quarkus. This is just for showing the differences and similarities here. So as you saw, it's basically the same application. So if we take a look at the code, I will stop this again. It looks very similar. We have our callee service here, which has, again, information about how to represent the endpoints. The difference is, while in Spring, we have so-called get mapping. In Quarkus, we have at get and at path. And there's another difference. This framework gives us also dependency injection as the same in Spring. In Spring, we do dependency injection to call our logic with add auto wired. In Quarkus, we have add inject. But that's mostly it. We go to the logic class. This has this dependency, which is called application scope. And in Spring, we have add component, which basically registers these components for dependency injection. But again, this is very similar. And we also have the cross-functional package, which also gives us the security, the exception handling, and the duration logging. But as you see, things are, at least for our quality service, there is on a code level not a lot of difference. What our applications also have is a Docker implementation. So if you see here, you can just build the application by saying clean package, of course, with Maven. And then you have two other options. You can tick this checkbox, and if we build this, we get a Docker image, a multi-arc Docker image, which will run on Intel and on ARM machines, so Apple Silicon, for example. And there is also another box that can give us native images, also for Spring. But this is currently only working for Intel machines. If our image is built, let's pretend it's built, we can just go into our terminal, go to source deploy Docker, stack up. We go into our browser. I have this nifty thing here called Portainer. We see here our quality service application is up and running. Let's take a look to the memory usage. We have here 118 megabytes of RAM for our small application. We can access our application in Docker and it works. And we can, of course, do the same for Quarkus. So also into source deploy Docker, we can say stack up, go back into our browser, quality service application starting, quality service Quarkus running. But the difference, take a quick look, is yeah, that's incorrect. Let's take a look into the dashboard because Portainer is sometimes lying. Stats, and we see it's consuming 12 megabytes of RAM, so much less than the other one. Okay, that's for the quality service. Then we can move on to the so-called person service. So let's now take a look into a more complete application, our so-called person service, which also accesses the database. And I have also to call my quality service. Okay, so we started the person service. We can access the person service on another port. We go to a localhost 50,800. Yeah, and log in. Looks very similar, but we have other methods here. We have, for example, now find all, which traverses the database and gives us all the data from the database. So we have some example persons here. We can say find by first name. We can access the first name here. So we have Fuma, so then we only get every person with Fuma. Find by last name Simpson, we get all the Simpsons here. And we can also do a so-called REST call. For this, I have to, of course, bring up also my quality service because one application calls the other one. Quality service coming up. And then say my name will call the other service and just return your name is Heisenberg, as we saw before. But this is for showing how to do a REST call here between two applications. If we take a closer look into our applications here, into our person service, we see that we now have some additional layers. The first layer is the so-called adapter layer, which helps us to do the REST calls. So in our logic class, we have this method say my name. We have the so-called quality service adapter injected here via @AutoWire. This is this guy here. And this will use the REST template to do a so-called REST call with get4object. This has some additional configuration in a so-called configuration class by Spring. This helps to, as the name implies, to configure our REST call. So this gives us some basic authentication here, because as we remember, we have to log in our application, and also if one application calls the other, you might need to log in. This is done here. It can also give us configuration for some timeouts and other stuff. Okay, that's for the adapter layer, very short and very concise for calling another service. And of course, we also want to hit the database. For hitting the database, we should also take a look into our application YAML. So this is the configuration we have for calling another service. So this is basically, this other service is currently on localhost, and this is username and password. And for the database, our application YAML also has some additional configuration. So we have a so-called data source here, which usually says that we use some kind of in-memory H2 database during development time, and we configure our database. And this also points to a so-called init script. And the init script, in this case, is basically an SQL script which creates the table. So it creates a person table, and it also creates a so-called audit table, something we'll get into later. Usually, for all these init scripts, you would use something like Flyway, and in Quarkus, we will see that we will Flyway here. In Spring, and also only for this demo, we are not using Flyway, we are using the Spring standard mechanism, which is invoked by these Spring parameters currently. Because, as I told, Spring can also be compiled to a native image in the same way as Quarkus can, but it has some limitations, and one of the limitations is that it's not possible to use Flyway yet. Okay, so then let's take a look into the code and how this works. So if we remember, for example, we have our find all method and our find first name. So how does accessing the database with Spring Data work? Because Spring Data is what we are using here. This is very simple. At the first glance, it uses a so-called repository abstraction, which we use here, the so-called person repository. So every time, for example, we do a find all or find first name, it delegates to a so-called repository class. This repository class extends from another repository, and we have to provide our object, which is business BO here, and the identifier, which is string here. And then we need to define our methods. So as we have a find by first name and find by last name in the application, we also need this here. And here comes the magic of Spring Data. So we have several options now how to access the database. We can use so-called JPQL queries, which you will see here, which is basically select P from person BO where last name gleich last name. This is one option, but we can even omit this, and we can just say something like you see here, find by first name, and then Spring Data will construct a query on its own. So what does this mean? This means that we could also remove this query and it will also work. Or we could say, let's take a look, what else do we have here? We could also say something like find by secret, string secret. And we, of course, need to return something. So we return the person BO here. And this would give us a query that will just automatically construct a query that will select all the data that equals with a secret. And So we don't need to create our queries on our own here. Again, there is a good documentation on everything Spring Data you can find on the internet that explains everything a little better. Okay, let's roll back that. And this is basically all you need to access the database. But having a database comes with a lot of additional costs. So for having a database in production, it's not enough to only read and write data. You have additional requirements, which could be multi-tenancy, which means that multiple tenants or customers are used by the same application. We are doing this here by a so-called discriminator. You should have auditing, which basically means that every time you access a database, you will have some kind of audit entry. We will see this later. And you also need encryption sometimes if you need to encrypt person-specific data. These things you find here are only examples, just as a disclaimer. These are not meant for productive use. These are just to give you an example how things could work. For example, for auditing, there could be other better alternatives. There are standard classes like, for example, Hibernate and Verse. So these are just to give you an example and a feeling how things could work. Additionally to our repository, we have usually with Spring Data and JPA, we have so-called entity classes, which define our entities. And here come the additional things like multi-tenancy and encryption into place. For multi-tenancy in our Spring world, you need to extend your BO, your business object, with this class tenant aware, and you need to put this additional where clause here. And this will automatically give you a filtering on tenants. So how does this work? This works by providing the tenant ID via a so-called HTTP header. I'm doing this with a plugin in Chrome. So if I have an HTTP header here, which is called xTenantID 0, this will automatically provide the tenant ID 0. If I say, for example, another tenant ID, this will currently not return any results at all because I don't have data here for this tenant. So going back to 0, and it will again return data. And this is mostly transparent. So we have one class, which is called tenant ID interceptor, which does the intercepting on HTTP level, which if you provide the tenant ID via header, it will save the header and then later on retrieve the tenant ID from the header to be used inside the database. I again won't get into too much details here. You just have to know extend from tenant aware, have the where clause, and then you don't need to care a lot here. Of course, you need to care a little because the tenant ID needs to be a discriminator in your database table. For the encryption part, which basically gives you the option to encrypt data, we have a configuration class again, which does IS-256 encryption on values. What you should have is a property which is called security encryption key in your application, and this should be provided. From the outside, this is usually something you set in Kubernetes or in your infrastructure somewhere. If you don't provide this, it will automatically generate for temporary usage an encryption key. It's just a random ID, but this is only for development. For production, you have to set a value because otherwise you will have problems. And to get the encryption up and running, the only thing you need is to annotate. We have this field here, which is called secret. And then you need to annotate your class with add type. You need to have this type here. And it then will automatically encrypt all the data. We can take a look how this works. So I will just bring up my application, which is already running, so I have to stop it. Again, I have to bring up my application in Docker because running this in Docker will also give us a database we can access. Then we can connect to our database here. And we can take a look at the data. So this is our person table, where we query the data with all our persons here. And you already see we have the secret here, which is encrypted. This, because this is, you see nothing here. And we also have the auditing, which automatically gives us, every time we create, insert, update, or delete an entry, it will give us a so-called audit entry. With an old value and a new value, and usually also with the user who did it. And a timestamp here and the operation at the end. And this is also working automatically here. This is covered by this audit section. But again, there are other frameworks like, for example, Envers, that might do it better. Okay, that's it for Spring. Let's take a brief look into Quarkus, because while Quarkus callee service is very similar, this service is a little bit different. So we can also do REST calls. Let's bring down our Docker application here. And bring up our Quarkus application here. Okay, reload. The only thing that changes is that we now have Quarkus, but basically we have, again, the same application here, H2 database during development and all the other stuff. And we have an exception, that's nice. Okay, on an adapter level, so if we want to call another service, there is already the first difference. So instead of what we do in Spring to have it to programmatically do a REST call, we just have an interface defined here. So we just need to have an interface which is called callee service adapter, and which has the annotations which are very similar we saw in our service class here. And that's it. We don't need to implement anything. We can then just add inject and add REST client, inject this adapter, and the adapter, again, it's just an interface. And then automatically Quarkus will construct the implementation because it knows how to call these methods. So this is very nice because we don't need to code all these REST calls ourselves. They will just be auto-generated during runtime for us. Of course, we might again need to attach things like basic authentication. We can do this with this register client header stuff here. We have again a configuration class that covers this. Also for persistence, there are also similarities and differences. We have again a repository class, but this repository class, in contrast to Spring, if we remember, in Spring, the repository class is just an interface which generates all the queries for us. In Quarkus, that's different. We have to extend from this so-called multi-tenant repository if we need multi-tenancy here. And this also uses some kind of mechanism that is called panache. There again, there is documentation on the internet, you can take a look, but the takeaway here is you have to actually code a little bit. So there are these so-called finder methods, which also need to have parameters provided, and with this you can access the database. And again, you have a mechanism here that automatically gives you multi-tenancy the same way we have it in Spring. as long as you take care that you extend from this repository. But in the background, it works a little bit differently. The auditing works very similar. The encryption works the same because as the same as Spring Data uses JPA in the background, this also uses JPA in the background. So our common ground is again our business object, which is basically a JPA entity. And from there, it's pretty similar. Okay, one final thing, if we go back to Spring, what we can also do with Spring is also building native images. If you remember, Spring usually gives us JVM images, which consume a little bit more RAM than with Quarkus, which gives us native images, which consume much less RAM. It is also possible to build native images with Spring. So if you take this box, and if you have an Intel machine, you will get a native image that you can run inside Docker. But this is currently in Spring, this is still beta. This has some limitations. We can take a look. Most of the stuff you saw here in this demo works. There are some things that do not work. So as I already mentioned, Flyway is not working. Resilience is currently not working, and there are only Intel builds. It's not working on ARM machines. So these are the limitations here. The Spring people are currently working on this. And you might also have to, every time you use reflection, you have to set some so-called type hints. So even if you do the REST call, this is why we have the things here, you have to set this type hints here. But this is something we might cover in another video, not for now. So thank you very much. That's it for today, and I hope to see you in the next video. Bye.